Hi guys, welcome back to our channel again. This is ChemXplain. I hope you had a really great day by now. In this video, we are going to elaborate on a new subject and on a new series which is called Analytical Chemistry, and this is going to be the first episode. As the most of you are familiar with this subject, a great amount of stochiometry science is going to be needed. So in the first couple of videos, we are going to practice it a little. Now, let's jump to the first question. It says, find the number of moles and millimoles of benzoic acid that are contained in 2 grams of pure acid. Okay, we can see that the molar mass of benzoic acid is already given in this question. So, we need to calculate the moles and millimoles. Let's go. I'm going to show benzoic acid with HBZ. So to calculate the moles, we can easily say 2 grams of benzoic acid divided by 122.1 grams per mole is going to give us the mole of benzoic acid, which is going to be 0.0164 moles of benzoic acid. Okay, we are done with the first part of the question, but still we need to calculate the millimoles of benzoic acid. Okay, let's have it really quick. When you have the moles of a substance and you want to calculate the millimoles, you can just simply multiply your answer by 1000. So here, the millimoles of benzoic acid is going to be 0.0164 times 1000, which is going to be 16.4 millimoles. I guess that's really simple. Now, let's go to next question. Okay, now let's take a look at this question. It says, what is the mass in grams of sodium ion in 25 grams of Na2SO4? Again, as it is seen here, the molar mass of sodium ion and Na2SO4 are already given in the question. So in the first step, we are going to calculate the moles of Na2SO4, which is going to be really easy. Okay? 25 grams of Na2SO4 divided by 142 grams per mole. So the answer of this equation is going to be 0.1760 moles. That's fine. Okay, this number is showing the moles of Na2SO4, but we are searching for the amount of Na, or sodium ion. We can say that in each mole of Na2SO4, there are 2 moles of sodium ion. So we can simply multiply it by 2. And our answer is going to be 0.3521 moles of sodium ion. That's fine. As the last step, we need to convert the moles of sodium ion into grams of sodium ion. Okay, so 0.3521 moles times 22.99 grams per mole. Okay, so the answer would be 8.1 grams of sodium ion. This one is also really simple. Let's go to next question. Our next topic is concentration of solutions. In analytical chemistry, we usually use 4 or 5 different kinds of concentrations with different definitions and meanings. Now, let's check them. The first one is molar concentration, that is divided into two groups, molar analytical and molar equilibrium concentration. The next ones are going to be percent concentration, ppm and ppb. ppm stands for part per million, while ppb stands for part per billion, which are going to be discussed completely in the next video. Now, let's go and find the definition of molar concentration. Molar concentration, which is shown by C index X, or Cx, equals Nx divided by V. But what are Nx and V here? Nx refers to number of moles of solute, and V refers to volume in liters. I guess the definition is really simple, so let's jump to the first question. It says, calculate the molar concentration of ethanol in an aqueous solution that contains 2.3 grams of C2H5OH in 3.5 liters of solution. Let's go. To calculate the mole of ethanol, we need to divide the grams of ethanol by 46.07 grams per mole, which is the molar mass. So, 2.3 grams of ethanol divided by 46.07 grams per mole. The answer is going to be 0.04992 moles of C2H5OH. Okay, now we have Nx. And also we have V, which is 3.5 liters. So we can say that molar concentration is going to be 0.04992 moles of C2H5OH divided by 3.5 liters is going to give us the concentration, which is 0.0143 molars, or 0.0143 moles per liter. That's great. Now, let's go to the next question. Fine, let's find out the difference between analytical concentration and equilibrium concentration. The definition for both of these concepts is Nx divided by V. But what is the difference? In analytical, we are looking for total number of moles of one species. However, in equilibrium concentration, we are looking for a concentration of particular species. That's fine. To understand this better, let's jump to this question. It says, calculate the analytical and equilibrium molar concentrations of the solute species in an aqueous solutions that contains 285 milligrams of trichloroacetic acid in 10 milliliters. It also says the acid is 73% ionized in water. Our first step is going to be calculating the amount of acid. So, amount of acid can simply be calculated using this equation. We can say 285 grams divided by 163.4 grams per mole is going to give us the mole of the acid, which is 1.744 times 10 to the power of minus 3 mole. That's fine. Now that we have the amount of the acid, we can easily calculate the molar concentration or the molar analytical concentration of the acid. So C index HA is going to be 1.7 744 times 10 to the power of minus 3 moles of acid divided by 0.01 liters. This is going to give us 0.174 molars, or 0.174 moles per liter. As it is shown in the question, it says the acid is 73% ionized in the water. We can say that our acid, HA, reacting with water, the products are going to be A ion plus hydronium ion. So A ion and hydronium are exactly solute species in our aqueous solution. Now, to find out their equilibrium concentration, we can say the equilibrium concentration of A equals concentration of hydronium ion. Both of them, they equal 73% times 0.174 molars. So the answer is going to be 0.127 molars for each of them, for A ion and hydronium ion. That's fine. Let's go to next question. Okay, let's practice this last question and wrap this session up. It says, describe the preparation of 2 liters of 0.108 molars of BaCl2 from BaCl2 connected to 2 water molecules. You can see that the molar mass is already given in the question. To start solving this question, we are going to calculate the amount of BaCl2 which is available in this solution, and then we can convert from mole to grams. So let's go. We can say that 0.108 mole of BaCl2 is available in each liter of this solution. So we can simply multiply by 2, and we are going to get 0.216 mole of BaCl2. Be careful, here we have BaCl2, and on the other hand, we have BaCl2 connected to 2 water molecules. So this can be really fine. BaCl2 connected to 2 water molecules. Just pay attention that the molar mass of these 2 are completely different. Now, let's go. We are going to convert this mole to grams. But how? That's really fine. We can say 0.216 mole times 244.3 grams per mole is going to give us 52.8 grams of BaCl2 with 2H2O molecules. That's fine, but be careful. The question says, describe the preparation. How are we going to describe? That's really easy. We can do it in just one sentence. We can say, dissolve 52.8 grams of BaCl2 with 2 water molecules in water and dilute to 2 liters. That's it for today. Hope you enjoyed the video. If you have any problem in these questions or on the topics that we discussed in this video, let us know in the comment section. So we are going to spend more time and effort on them on the next videos and on the videos which are coming. Thank you so much. Don't forget to subscribe and like. Goodbye.